Lab, we're going to react lithium and then sodium and then potassium, 3 alkali metals, group 1, with water. They're currently stored in mineral oil to keep them away from the atmosphere. They react readily with oxygen. They react violently with water. So, on the board is the example. Here's sodium metal, sodium solid, free element, oxidation state 0. It's going to do a single replacement reaction with water. That's the primary reaction. It's going to kick out hydrogen, but hydrogen's off-bring chlorine, so it's diatomic. So to balance it, you're going to need 2 of those, which is going to give you the 2 sodium plus 1 ions here, which means you're going to need 2 sodiums here. So your coefficients are 2, 2, 1, and 1. And you have NaOH as another product. The hydrogen gas, sure, but sodium hydroxide, that's group 1. It's going to be soluble. This is going to be dissociated in water. And the hydroxide ions are going to form an alkaline or alkali, a basic solution. And we're going to use an indicator called phenolphthalein. Phenolphthalein, yes, that's how you spell it. It turns pink in the presence of a base. Well, that hydrogen, if you have sufficient hydrogen, is going to react with oxygen that's in the air. And hydrogen is an explosive gas. It's going to do a synthesis reaction, and it ought to go boom. So I'm going to put some gloves on and get a piece of sodium here. And we'll talk about some of the properties of the sodium. So why am I storing it in oil?
So that it doesn't oxidize.
Yeah. So if I grab a piece of the sodium, first thing you notice is I can just stab it.
Whoa. Tofu.
Get in there. So I'm going to try to wash off or dry off, not wash, no water, no bueno. Here's this chunk of sodium. You notice it doesn't look very metallic on the surface. It looks kind of oxidized already. Remember our empirical formula lab? And we had to scrape the magnesium oxide off the surface? It would be the same kind of deal here. This is much more reactive than magnesium. Let's cut it open. It's highly malleable, and on the inside, considerably more lustrous, yes? Okay, so here's my piece of sodium. I'm going to leave that here for a second. Here's my phenolphthalein. I have some water under the fume hood here. Phenolphthalein is colorless in the presence of an acid or neutral. It's not distilled water, but it's fairly neutral. So here's my piece of sodium. What was the color of the flame test for sodium? Orange. Are you ready? Can everybody see? Okay. So what we should see is some gas evolving. We should see here's some fizz. It's a little bit less dense than water. It should float. But it reacts violently enough to accumulate a bubble of hydrogen gas, and it's on fire. And hydrogen burns. The pink is from the phenolphthalein. Hydrogen explodes. I think we're done.